Before we start with our sample problems, here are the integration formulas we needed. Number 1. Evaluate the integral of sine of for x, cosine of for x, dx. Since there is two trigonometric functions, and one can be the value of u, and the other can be the derivative, we will use the power formula for this one. First, let's assign the function sine of for x as u, and n should be 1. Then, get the derivative of u, that is 4, cosine of for x dx. Modify, use du equals to 4 cosine of for x dx, then multiply 1/4. Copy 1/4, then integrate using power formula. And here's our answer. How about we use the value of u equals to cosine of for x? The result of this will be different from the first one, but they are both correct answers. If it is your first time seeing our video, and have questions how to modify before integration, visit our first tutorial video in integral calculus. You will find it very helpful. And here's the another answer for item number 1. Let's proceed to number 2. Evaluate the integral of cotangent of 2x dx. We will use the formula of integral of cotangent of u du. From the given, u is equals to 2x, and the derivative is to dx. Since the derivative of u should be to dx, we have to modify it before we integrate. Copy 1/2, then use the formula. Natural logarithm of sine of 2x plus c. For number 3, evaluate the integral of quantity of secant theta raised to 2 d theta over quantity of tangent of theta plus 3. Let's investigate first. Can we solve it by using this formula? We can't use it due to the presence of this function at the denominator. Now, let's try power formula. If use value of u equals secant of theta, n equals to 2, the derivative is secant of theta tangent of theta, d theta, which is not present from the given. So this is also not applicable. But if we use the denominator tangent of theta plus 3 as u, the derivative is equals to the function at the numerator. Therefore, the formula we should use is the integral of du over u equals to natural logarithm of u plus c. Since derivative of u is the same as given, we don't have to modify it, and the answer is natural logarithm of the quantity of tangent of theta plus 3 plus c. We are now at number 4. Evaluate the integral of cosecant of 5t, cotangent of 5t, dt. Though we have this formula specific for this integration, we still need to check if the derivative of u and the given are the same. From the given, u is 5t, and its derivative must be equals to 5 dt. du is different of coefficient of 5, so we must modify it before we integrate. We put 5 on the right side of the integral side, then we put 1/5 on the left side. Copy 1/5, then use the formula, and this is the answer. For number 5, evaluate the integral of quantity of cosine of y squared dy. As we investigate, we cannot use power formula, because there is only one function, and we can't use the formula for integral of cosine of u, because of the exponent 2. All we left is to use trigonometric identity to transform this into simpler function. From the cosine of double angle, we can transform it into cosine of 2y plus 1 all over 2. And this will become 1/2 of integral of cosine of 2y dy plus 1/2 of integral of dy. For this integration, we use this formula. And here's our answer.